Okay, so it says find the dot product, and they give us two vectors, and then find the angle between the two vectors. So we can find the dot product. V sub 1 dot V sub 2. Okay, and that's going to be 5 times 3 plus 2 times 7. Ah. So what do I get? 15 plus 14, 29. That's the dot product. There, keep that in mind. Okay, so we need that. All right, to find the angle between the two vectors. So let's draw a picture of what's going on. So vector 1 is, 5, 2. So it's going like out here, and that would be V sub 1. Vector 2 is 3, 7. So it's like, I don't know, not quite that high probably, but up here someplace. What we're trying to find then is this angle theta between vector 1 and vector 2. Now notice that you're in the first quadrant. I'm going to do it my way, then I'll talk about how the book does it. Okay, so cosine theta is equal to, and then it's V dot U, which we already figured that out, and by the way, those are vectors, over the magnitude of V times the magnitude of U. Okay, so I have to find the magnitudes. What will the magnitude of V be? Well, it's going to be the square root of 5 squared plus 2 squared, sorry. So that's going to be 25 plus 4, which is the square root of 29. And then what's the magnitude of V sub 2? You know what? I forgot we're not doing V and U. They're V sub 1 and V sub 2. Okay. The other vector is going to be the square root of 3 squared plus 7 squared, which is 9 plus 49, which is 58. Okay, so what I get from this formula then is the cosine theta is going to be the dot product, which I already know, 29, divided by, and it's the square root of 29 times the square root of 58. Okay? Now, your calculator, they just put it in, or I'm sorry, your textbook, they just put it in the calculator, which you can do, and a lot of times the numbers don't work out nicely. But in my mind, I'm thinking, well, I know 58 is 2 times 29, right? So I'm thinking 29 times 2 times 29, or 29 over 29 times the square root of 2, if you're simplifying that, and then you get 1 over the square root of 2, or the square root of 2 over 2. And then I'm like, okay, well, I know the cosine, when the cosine is the square root of 2 over 2, I have to be in the first quadrant, because both my vectors are in the first quadrant. And so I'm going to have an angle there of 45 degrees. Okay, so that's how I would do it. Theta equals 45 degrees, and I'd be done. But to show you the calculator way, because it might not always work out super nice. So you have the cosine theta of 29 over, so then take and multiply out those square roots. You get the square root of, I don't know, it's 16, I had it on my calculator, 1682. And then what you'll have to do is you'll have to find theta, you'll have to go inverse cosine, and then it's going to be 29 divided by the square root of 1682. So I'll do this on my calculator real quick here. So inverse cosine, and then it's going to be 29 divided by the square root of 1682, and I get 45. Thank goodness my calculator was in degrees. Okay, so you do get 45 degrees still. So you can do it with a calculator, or you can just do it with some algebra. And I'm a fan of the algebra, so it's like, why would I bother finding my calculator? But anyway, both options available for you. A lot of times theta is not some convenient angle, so then you kind of do have to go to the calculator.